This is the how-to on electron configuration, the diagram, and the quantum number of vanadium. Vanadium is in the D block, and to get to the D block, we have to go through energy level 1 of the S block, energy level 2 of the S block, 3 and 4, as well as energy level 2 of the P block, and 3 of the P block, and the 4th energy level, but since it's in the D block, it's -1 energy level, so it's actually the 3rd energy level. So to start, we do the 1st energy level in the P block, or the S block. And there's actually 2 elements in the S block. Helium gets moved over here. And since there's 2 elements, they have 2 electrons. And 2 electrons can fit in 1 orbital. So to represent that, we'd have an arrow going up for 1 electron and 1 going down for the other. And we'd do the same thing for the 2nd energy level. And then we'd have to move to the right of the periodic table to the P block. And that's at a different height, so we'd move that over a bit up here. This has 3 orbitals since there are 6 elements here, and we just divide that by 2 since it has 6 electrons, and that will fit in 3 orbitals. So again, we'd fill these orbitals with these electrons. And from here, we'd move all the way back over here to the S block. I don't know why I wrote a 2nd orbital. And we'd do the same thing with the P block as we did with the 2P block. And now that we're done with the S block, we can finally do the D block on energy level 4, but for the D block it's energy level 3. So we'd move that even farther over since the D block is at a different energy than the S block and the P block. This has 10 elements going across. We divide that by 2 to get 5 orbitals. This is in the D block. And we'd count 1, 2, 3, 3 for vanadium. And we'd represent that with 1 electron, another electron, and another electron. These fit different orbitals since they have to have 1 electron per orbital before they can do 2 in 1 orbital. So this would be the whole entire electron diagram for vanadium. And for the configuration, you can just take all of these first letters and numbers and you just write it out. So it'd be 1s squared since it has 2 electrons. Same with 2s, there'd be a 2. This would have 6 because it has 6 electrons. I'm going to just repeat the pattern. And 3D, if this was completely full, it'd be a 10 here. That's the highest it can go to. But we only have 3 electrons, so we'd just do a 3 up here. The electron configuration, diagram, and quantum number is all unique to an element. So no other element except for vanadium is going to have this electron configuration and diagram, and it won't have the same quantum number. To get to the quantum number, you need 4 things. You need N, L, M, and M of S. To get N, it depends on the energy level. Vanadium's in energy level 4, but since it's in the D block, it's -1. So N is going to equal 3. L is going to be 2. The L depends on what block it's in. So it's in the S block, it's going to have a L of 0. If it's in the P block, it's going to have an L of 1. Since it's in the D block, it has an L of 2. And if it was in the F block, it had an L of 3. So that's that. For m of our quantum number, we can get it from the orbital. So for this orbital, we do -2, -1, 0, 1, and 2. And since it ends at 0, our m is going to be 0, because that's where the electron ends. So this is going to be 0. And then for m of s, it depends on whether the electron is up or down. And since it's up, it's going to be 1/2. M of s can only be -1/2 or 1/2. And for the m, if it was this, it'd be -1, 0, and 1. That's the only thing it can be for m. For this, it would just be 0. And if it was in the F block, it'd be, I don't